Hello, great minds. You're welcome to today's class. In today's class, we'll be dealing with set theory. Set theory. So this is the second topic. This is the first topic. This is for the mathematics. The first topic to be treated. Okay. These are the content you're going to consider. The contents to this particular set theory. The content include definition. That's just like introduction to set. Okay. Then we have set notations method. Then we'll be having types of sets such as null sets, singleton sets, infinite, universal, power, and subset. These are the types of sets that we'll be considering as we dive into the topic. Then we also have set operations such as union, intersection, complement, number of set, or you call it cardinality, set cardinality, a number of elements in a set. Then lastly, we'll be considering Venn diagrams and applications up to 3 set problem. So those are the content of what we are going to do. So now, the first aspect is to look at definition and introduction to set. So we have definition. A set is a collection of distinct objects, things or numbers. So it's a collection of what? Of distinct objects, things or numbers. So that is the simple definition of what? Of set. It means a group of anything, like group of students, set of books, something like that. You call it what? Set. So now, for example, we can have a car. A car can form a set. That's a single set. Then we have numbers. Numbers can form sets. We have cutlery. Cutlery. That's your spoon, your fork, and all that. They can form a set. Then we have a set of book. Okay. Can also form a set. Then again, we look at some examples. Generally, something like collections of books in public or private library. So when you enter any library, you see collection of books, like maybe books that are meant for sciences, book for mathematics, book for engineering. You see they group them in different area sections. So they are all what? Set of books, set of science books, all of that. Then we have a collection of tools in the carpentry workshops. We have different kind of tools we use in the carpentry workshop. So the collection of those tools are called what? Are called set also. So basically, we can conclude that any clearly defined collection of what? Things, objects, or numbers constitute a set. Take note of that. I hope this introduction is okay. Then let's take a look at some other aspects. As we proceed, as we progress along this content, okay, we'll be subsequently giving evaluation question. Now let's take a look at this one. It said a set is a dash of object, things, or numbers. So if you could remember very well, you say what? You should be able to say that yourself. So try and say that and put it in the comment section. Let's know what it is. So we have then we have set representation. Set representations. Okay. Now let's take a look at set representation. How do we represent set? It said each member of a set is called an element of the set. Capital letters such as X, Y, Z are used to denote what? Set. While small letters such as X, Y, Z are used to denote the element of a set. So that means we don't use capital letter as what? As if we are meant to use the letters. Mainly, most of the time we make use of letters and numbers. So if you are making use of letter to represent our element, it has to be small letters. If you are making use of letters to represent our set, it has to be what? capital letters. For instance, you could have something like this X. You can see this X you have here is a capital letter. It's a capital letter. Why this one is what? They are all small letters, isn't it? They are all small letters. So that's that. So and you use curly brackets. Curly bracket to these are curly brackets. That's the left bracket and the right bracket to enclose the elements. And also note that the elements are also called member. Member of what? Of a set. Take note of that. Okay, let's move ahead. We're going to take a look at the basic set notations that we have. The basic set notations we have include one, you have it as a curly bracket, or you call it curly braces. Okay, that is the one I just finished talking about. So we have what do we use it for? Used to list elements of a set. Okay, we used to contain the elements or the members of a given set. E.g., we can say A is a set and it contains elements which are enclosed in the curly braces as the way it is written, which include what? 1, 2, 3. So there are 3 elements in a set A. So this is how we represent set. Always use what? Curly braces to represent what? Set. Not block bracket nor curved bracket. We don't use those ones to represent a set. We use curly braces to represent set. So what does this thing mean? It means set A contains elements 1, 2, and 3. The next one is set membership. Set membership. This indicates that an element belongs to a set. Okay, we use this sign to represent what? Or you call it notation to represent what? To represent to show that an element belongs to a particular set. For example, you could have 3 is a member of what? A. So this sign that looks like E, we call it set membership. Okay, so sometimes we call it belong to, okay, or a member of. So it means 3 is a member of A. For example, if you have like maybe A contain a natural number from 1 to 10. You understand? Let's say A contain natural number from 1 to 10. You understand? So that means 3 should belong to A. So it could be written what? This way, that 3 belong to A, or 3 is a member of A. So that is a way of explaining set membership. So what if it's not? So you talk about what? Non-membership. So indicate that an element does not belong to a set. So in that case, we put a slash on the sign belong to. So it is written like this, like 4 does not belong to A. Like let's say A includes elements like 1, 3, 2, and 5. You understand? So there is no 4 there. So you can write 4 does not belong to A. This is the way it is written. So let's proceed. We have subset then. Our subset. You say a set is a subset of another set if all its elements are contained in the other one. Okay? A set is an element of is a subset of another set if all its elements belong to the other one. Like if I have 2 sets, let's say A and B, and A contain 1 to 10, while B contain 2 to 3. Okay, 2 to 3. So 2 to 3 can also be found from where? Can also be found in 1 to 10. So that means B is a subset of A. So that's just how to explain the subset. So something like this, we use this sign to represent what? Subsets. Like a C with an underscore. So that is a sign we use to represent what? Subset. So it is read like this: A is a subset of B. So that's that. And let's take a look at this. This one is talking about proper set. Okay, proper set. So he said a set is a proper set, is a proper subset rather, is a proper subset. A set is a proper subset of another if it is a subset and not equal to the other set. So what do we mean? What do we mean by this? It means when I gave the example A and B are two sets, so then A contain 1 to 10 and B contain just 2 and 3. Okay, so that means B is a proper subset of A. You understand? It's a proper subset of A. Let's assume we have A to contain 1 to 10 and B to contain 1 to 10 also. Okay, so B is not a proper subset of A in this case. It's not a proper subset because they have equal number of elements and the same kind of element. So they are not what? They are not B is not a proper subset. Okay, for you to say it's a proper subset, it means it shouldn't be equal to A. So that's it. So for example, we have this. We use this sign to represent it. That's A is a proper. This is a proper subset without underscore under it. Proper subset of B. So followed by this, we have superset. Superset is like the opposite of proper. Is the opposite of subset. Okay. So a set is superset of another if it contains all elements of the other. Okay, like when I use the example, A contain element 1 to 10 and B contain just element 2 and 3. Okay, since B is a subset of A, that means A is a superset of B, so it can be reread that way. A is a superset of B. It means if B is a subset of A will definitely be a superset of B. So it is written this way. You can see we have changed the direction. The direction was like this before. So it was facing the other side, facing the right hand side, but here now it's facing the left hand side. So that's how it is written. B is a what? Is a superset of A. This is an example that I just gave. But this one, you can see they made use of A as what? Subset of as a subset of B. Then B will definitely be what? Superset of A. Altogether. So that means that the B must contain what? The higher element. That's the meaning in this case, in this particular explanation. Then now we have proper supersets. Proper superset. So a set is a proper superset of another if it is a superset and not equal to. Okay, so it means that they must have distinction. One must be greater than the other. They shouldn't be equal to before you can detect superset. Proper superset or proper subset. That is what this one is explaining. Okay, then we have example B is a superset of what? Is a proper superset of A. So then the next one is empty sets. Empty sets can be denoted with these symbols, this or this. So you can see this is your curly braces, right? So when you just write a curly braces without anything inside, it can be used to represent empty set. Or you just draw this sign, used to represent empty set. And it means what? A set that has no elements. That is what you call empty sets. Sets without elements. So this is an example. A is a set, but it has no what? Element. So it is written that way. Then the next one is universal sets. Universal set, you use this sign to represent universal sets. Look at it here. It looks like U. You use it to represent universal set. So what's the meaning? The set containing all elements under consideration. The set contain all elements under consideration. That is what we call universal set. Okay, let's take a look at this short example. It said if X is the set of all prime numbers, if X is the set of all prime numbers and P equals 7, then P belongs to X. Is that correct? Yes, it is. Because 7 is what? Is a prime number. So if P equals what? 7, it means P belongs to X. Because according to them, they said X is a set of what? All prime numbers. So that's correct. Then now, if A equals 6, can I say that A belongs to X? No way. A cannot belong to X because 6 is not a what? It's not a prime number. And prime numbers, you all know the meaning of prime numbers. Prime numbers are numbers that are divisible by themselves and one only, isn't it? So that's that. Then we have this note for us. It said a set is completely specified in the following ways. A set is completely specified in the following ways. Now, the first one is that by listing out all the members of the set. If you are given some set that the elements are not actually, you need to obtain the element by yourself. So you call it set builder. We are still going to talk about that one. So you need to do what? You need to list out the element. The secondly is that by describing the element of the set, you need to describe the element of the set. Okay, you need to describe the element of the set. How do you describe the element of the set? How many elements are there in the set? It's part of the description. Okay, so is it a single set? Is it empty set? Is it, you understand? So those are the things that we are talking about. Then we have the C part of the question said of the note. It said by enclosing the members or elements in a curly bracket or braces. So it means that these are three notes, for you to take note of. Okay, to be careful of. Anytime you are dealing with set, you must always make sure you work with this. Make sure your elements or members are enclosed in a what? In a curly braces or bracket. Not curve, but curly. Curly, okay? That's that. Then now look at these evaluation questions. We have the number one. It said, what is an element of a set? Try and answer this question on your own. What is an element of a set? Then write out another name for element of a set. Then what is the meaning of the following signs in set notation? Something like this. What does it mean? What does this one mean? Then thirdly, if y is a set of even numbers and q equals 9, then q is what to y? So you should be able to answer those simple questions. So we're going to be ending the video here today. So our next video is going to be on types of sets. Stay tuned for the next video. Thank you for being part of us. Please make sure you comment, subscribe, and share to others. Thank you for being part.